Hi, this is Mrs. Bustamante. Today we're going to start talking about kinetic theory and states of matter. This first part is actually going to be a review of some things we did first semester, but I just want to bring it back to your mind. So as we talk about kinetic theory, we're going to say that matter is made up of molecules. We already know that. And these molecules are actually in constant motion, just like kinetic means moving. And we talked about first semester how solids are packed and liquids are packed and gases, and even mentioned that there are these things called plasma, right? And how those particles move or don't move in those different states and what retains its shape or volume and can move. So I want you to take a second. You have a chart that looks like this. Think about how are solids and liquids similar and different from gases in terms of this idea that they're made of molecules and those molecules are in motion. So here's the property it gives you, and then you have gases, liquid, solids. I want you to take your best guess. Think about what you think these things mean and how they compare in solids and liquids and gases. Take a moment right now to go ahead and pause the video and fill in this chart. Okay, hopefully you went ahead and filled in your chart. Now we're going to do it kind of together. You can fill in your missing holes or correct anything you might have. So what about spacing of particles? Well, in particles, those molecules are really far apart. In liquids, they're closer together than gases, and in solids, they're the most closely packed. That means that in gases, those particles move the fastest. Liquids, a little bit slower. They can slip by each other still. And in solids, they're actually in a fixed position and they just vibrate there, so they can't move as freely. Average kinetic energy, we're going to talk about kinetic energy. That's just how fast are they moving, really. Gases, because they're moving so fast, tend to have a high kinetic energy. Liquids, it's lower than it is in gases, and solids, it's going to be the lowest of the three. What about the attraction between particles? How much do particles like each other or not? Well, in gases, this attraction is really low. In fact, a lot of times we're going to say that there's no attraction between particles in this unit, so we can talk about their movement freely. Liquids, they have more of attraction. They have things like hydrogen bonds, intermolecular forces that mean one molecule is slightly attracted to another more than gases, but not quite as much in solids. Solids have the strongest bonds. Think about an ionic bond being the strongest type of bond, right? Disorder or order, how unorganized are things? Well, gases tend to be really disordered. They go freely, they move wherever they want. There's no organization to them. Liquids tend to be a little bit less disordered due to these forces that pull them together and because they're a little less mobile. And then solids are the most ordered. They tend to be in fixed patterns that don't really change so much. What about the volume, the amount of space they take up? Well, gases can take up an indefinite amount of space. In fact, we can even compress them so they can be bigger or smaller because they have space between those particles. Liquids have a definite volume. Think about trying to pour a big, huge glass of water into a smaller one. It won't work, right? And solids also have a definite volume. You can't change it. Shape, well, gases take the shape of the container, so we say it's indefinite. Liquids do the same thing. They have an indefinite shape. It can change, but solids have a definite shape. That's the shape that they're in. It kind of just is how it is, right? So what about fluidity? Do the particles move past each other? Yes, in gases, pretty fluid. Liquids, yeah, still pretty fluid. Those particles move a lot, but in solids, no. Now, in fact, we can talk about some amorphous solids, or actually, like your window panes are liquid, or really back in the day they were. Glass is a liquid, right? And over enough time, because it will move down with gravity. So if you look at windows in a really, really old building, you will notice that at the bottom, they're thicker than they are at the top. That's because they are actually liquid, and over time, even though it appears to be solid, it has a really, really slow flow rate that follows gravity. Density, remember density is mass over volume. So the particles are the thing with mass, and if you don't have a lot of them in a cramped space, so to speak, you're going to have a low density in gases. Liquids tend to be higher in density, and on average they're about 10% less than their solid state when they're in a liquid state, and solids tend to be the most closely packed. Now remember, Water is kind of an exception to this rule, but we're talking in general terms. What about compressibility? Can we take something and make it smaller? Gases, yes, very, very compressible, sometimes up to 1,000 times compressible or smaller than they started with. Liquids, relatively incompressible, about 4%, pretty much like solids, right? Solids, even less compressible. You can't take them and squish them into a smaller space. Diffusibility, can it move from one place to another? We're going to talk a lot about diffusion. Gases, yes, very diffusing. Liquids, yes, but it's slower because they have attractive forces between molecules, right? If we increase the temperature, though, we're going to increase the rate of diffusion, which we can actually see with some other particles too. And solids are just millions of times slower even than liquids, so they really have a poor diffusibility rate.